everyone. My name is Justin Smith. I am with NASA IV&V. It's Jennifer Neptune, the lady you saw helping me out up here. And this is part of the NASA IV&V Speaker Series. And what this is we try to go around to different schools in the area. We've already done one of these WVU earlier this spring. And just help you guys learn about what's going on down the road at NASA IV&V, as well as what's going on in NASA in general. And today we're going to show you guys a spot presentation. So Nate Tehrani is from WVU. He is from the space group. He's going to talk to you guys a little bit more about that. But today he's going to give you guys a little bit of history of what NASA is doing with Mars right now, what we've done in the past, what we're currently doing, and what we hope to do in the future. So with that, please enjoy Nate's presentation. You might see some kind of questions pop up here in this box. That's why we're using WConnect. We're actually being broadcast live to different universities across the state, as well as people maybe just watching at home in the dorm room. And everything you're going to see here today is going to be recorded, so for any reason, when your friends couldn't make it, we'll be able to get the link out so you guys can watch the video. All right, so thanks again. Enjoy Nate's presentation.
Oh, well. Hi, everybody. Like you said, I'm Nate, and I'm from the group Student Partnership for the Advancement of Cosmic Exploration. It's a club that started at WVU and we've expanded to a couple colleges, and I'm really interested in starting a group here. So if anyone's interested, talk to me about that later. Anyway, I'm here today to talk about the history of Mars exploration, basically what we know about Mars and how we figured that out, and then also a little bit about the future. So, go ahead. So, the beginning of humanity, this is what Mars looked like to us, and that's all we knew about it. Just one point, one dot, one tiny bit of information. All we knew was its color, and it was red. And it was unlike any other star in the sky. This was before there were airplanes and whatever else in the sky. So, among all of these bright white stars, there was this big red, little red thing. And it got people curious about what it was. And this planet, well, they didn't know it was a planet, but this object moved differently than the planets in the sky because it was in the solar system. It would appear to go backwards and forwards in the sky during the course of the year, which was totally odd. So the Romans decided to name it after their god of war, Mars. So eventually we developed telescopes, and we figured out that Mars was a planet, just like all the other planets, all 8 of them. And there you can see them to scale with each other and with the sun. Now note that this is to scale size-wise, but not distance. You can see that Mars is fairly small compared to the Earth, and definitely small compared to the so-called giant planets. And so there's a little bit closer up. Mars compared to the Moon and the Earth. It's about half the size of the Earth, twice the size of the Moon. So it is really interesting, some of the landforms that I'll show you, because they're really quite large. In fact, they're on such a small planet is interesting. So a little bit after we first seen Mars in the telescope, we developed some better ones. They weren't perfect. And so we started to see Mars like over there. And it was basically just a cloudy disk. And that's all we really saw. And the fact that it was so hazy, that's all we got to see. Got people very, very excited, very, very curious, because they wanted to see it better. Now there were a few astronomers who kind of saw things. So here's a picture of Mars that was drawn by Schiaparelli. He was an Italian astronomer, and he had some cracks in the telescope. He didn't quite see things quite right, so he drew those lines there, and he called them canals. And what he thought they were these canals that were being constructed across the surface of Mars by some kind of civilization that was trying to save water from the poles and pipe it down to the desert-like equatorial region. No one really knew, so that was the best explanation they had. And another astronomer, Lowell, made this map of Mars. And again, it had these canals on it. And the things that Lowell and Schiaparelli thought they saw got people really, really, really excited about Mars because they thought, well, there were Martians, buildings, cities, basically people on the surface of this other planet. Oh, sure. All right. Okay. But eventually we developed better telescopes and we started to see that Mars didn't have this civilization on it, but we were still curious. So about the middle of the last century, we developed rockets that were powerful enough to send cameras close up. So here's one of the first ones. That's an Atlas rocket, and that particular rocket is sending one of the early Mariner probes to Mars. So I'll show you a quick video about what it looks like to send a rocket to Mars. Justin's going to play my video for me. Basically, it's what's called a Holman transfer, and it's an egg-shaped orbit that intersects with Earth at the low point, intersects with Mars at the high point. So it's the most cost-effective, fuel-effective way to send something on a journey to a planet farther away from the sun is. Farther away from Earth is from the sun. Did you notice that it was still spinning at the end? Did anyone think of why they would want a spacecraft to be on a continuous, easy, slow spin? Artificial gravity. That's something that we're definitely going to use when we send people to Mars. But for a robot, we don't really need it. The actual reason is because of heating. So you know a rotisserie mount. One side of whatever you're cooking gets hot, and the other side gets cold. So you have to keep it turning. Well, in space, the sun side on any object is plus 250 degrees, and the cold side is minus 250 degrees. So whenever spacecraft are sent far out into space, then they're put on a very, very slow continuous roll, just to make sure that the whole thing moves. And so these were the first spacecraft that we sent to Mars. They got to see it close up. And this was actually the first that made it. It was called Mariner 4. Mariner 4 had a couple of primitive cameras on it. And that picture down there is the first one it took. It doesn't really look like a very good picture, does it? I mean, when I see that, it makes me want to take a better one. And so that's exactly what NASA wanted to do. And Mariner 4 didn't really get a chance. Mariner 4 was sent on what was called a flyby trajectory, which meant that it would go toward the planet, kind of loop around just a bit, and then fly off into space. So what NASA really wanted to do was send something that would stay at Mars. So this was Mariner 9, this bigger one. so that it would become Mars's satellite, just like all the satellites around the Earth. And Mariner 9 had the opportunity to take better pictures with a better camera and a lot of them. So here's an example of one. It's called Noctis Labyrinthus, and that translates to the labyrinth of the night. And it's a system of canyons and canals. And so these weren't artificially made. They weren't made by people, but they were made by what might have been water. And that got NASA excited again. They thought, well, maybe there was water there. Maybe. So it was decided that we would launch more missions to Mars and figure it out. And so here's another close-up of Mars. And you see that large, dark object in the center. Does anyone know what that is? Maria? Kind of close. That's a feature on the moon, also very dark. But this is actually a canyon. It's an enormous canyon. It was named after its discoverer, like things on Earth are. Its discoverer was a robot called Mariner, so they call it Valles Marineris. And Valles Marineris is the largest canyon in the whole solar system. It's the largest canyon we've ever heard of. And so it's about 2,500 miles from end to end. And I find that kind of hard to picture. So that's how it would look compared to the United States. The Grand Canyon, we like to think of as really, really big on Earth. And it is for Earth. But, it would just be a tiny speck compared to Valles Marineris. And if you could stand on the edge, this is what it would look like. Actually, I lied. If you could stand on the edge of the Grand Canyon, that's what it looks like. But this other photo is what Valles Marineris looks like from space. It just completely blows the Grand Canyon out of the arm. I'd love to go rock climbing in that. And here's another landform on Mars that's really, really huge. Has anyone ever heard of Olympus Mons? It's the largest volcano in the entire solar system, one of the largest mountains that we know. This thing is about as big as the state of Arizona, which again is kind of hard for me to picture. So there we go. Kind of gives the mountain state a whole new meaning. And you see those edges there. Those are actually near vertical cliffs. So this thing is a shield volcano, kind of like the volcanoes of Hawaii. And back when it was active millions and millions of years ago, the lava came up out of it. I'm sorry, magma. They're in geology. You're going to give me a hard time about that. Magma came up out of it and kind of cooled off and cooled down the sides. But there were these vertical cliffs on the sides. And those cliffs that you can kind of see there don't look too big, but they're actually 5 miles high. So again, 5 miles is hard to be a picture. But if you've seen some airliners fly over and they have their contrails, those are 5 miles high. So picture a cliff that tall. Again, Mars is not a big planet. It's pretty small compared to the Earth, but it has these amazingly huge landforms. And that's not the only volcano. There are a whole system of volcanoes in an area called Tehrani. They're almost as big, and they're all bigger than all of the mountains on Earth. And so there's another picture. You see Mount Everest. We make a big deal out of it on Earth, and there's Maxwell Mars on Venus. But basically, you could put the two of them together, and it would be almost as high as Olympus Mons. And so the next step after Mariner, we could take a close-up picture, had things in orbit, but we wanted to get even closer. So in 1976, NASA sent 2 Viking missions to Mars. And each Viking had 2 parts. There was the upper part you see there, and that was the orbiter. It was basically a satellite, kind of like Mariner, but it would stay in orbit and communicate between the lander and Earth. And then you see inside the aeroshell there was the lander. And that would land on the surface just like its name implies. And NASA sent 2 of them to land in different locations for 2 reasons. 1, to see what different areas of Mars look like, and 2, just for redundancy. It's always meant to have backup. Again, this was sending robots to another planet. Pretty risky. so they did chemical analysis of the soil and of the air, figure out what the air was, what the soil was made of, and whether or not there were bacteria there, whether or not there could be bacteria there. Eventually, they found out it was inconclusive whether there was life in the soil, and so it's still not known for sure. And so here's one picture of Mars, one picture of the Earth. So I like this part. Who thinks that this side here is Earth or Mars? Okay, go ahead and do it. Basically, the one with the blue sky is Earth. The one with the not blue sky is Mars. Although there is one time during the Martian day when the sky is blue. And I'll get to that in the end. Not to spoil anything. And so after about 20 years of basically not doing anything at Mars, NASA got the urge to go to Mars again. And it did so in basically the late 90s, so right when I was starting to pay attention to things. And it did so with these 3 missions. So the first one was Mars Global Surveyor. And you see that it's that satellite-looking thing over there. Thanks for pointing, Justin. And you see that object on the bottom. That's actually a camera. So Mars Global Surveyor was kind of like our first spy satellite on Mars. It was able to take very, very detailed photos of the surface. And it did so for the whole surface. Like its name implies, Mars Global Surveyor was there to make a map of Mars. And that it did. So just like Google Earth was taken by satellites, Google Mars was taken by satellites. If you have not checked that out on the internet, I urge you to. It's very cool. I've spent a couple hours, on Google Mars. It's really fun. And another mission was Mars Odyssey. That was sent in 2001. And, kind of like 2001 Space Odyssey for all the science nerds. And Mars Odyssey had what was called a gamma ray spectrometer. And gamma rays, kind of like X-rays, they can go through things. And the gamma ray spectrometer is that object on the end of that loop. And it was used to image what was underneath the soil on Mars, down to a depth of about 3 feet or so. And then there was Mars Pathfinder with Sojourner. Pathfinder was also sent in 1997. And when it landed on airbags. And so parachutes don't really work on Mars. The air is a little bit too thin. So instead, they had to figure out a better way to basically bring things to a stop on the ground. And so Pathfinder landed on airbags. It's another cool thing to Google because there are no videos or picture of that here. But basically, the entire spacecraft had these balloon-shaped things on it when it was falling through the atmosphere. And when it hit the ground, it bounced around for about half a mile. And then eventually, once it stopped, it inflated the balloon and unfolded like a flower with its petals. And on one of the petals was this. That's Sojourner, the first rover that NASA ever sent to Mars. It was more of a test bed than anything else. NASA wanted to find out the best ways for designing, building, and operating rovers on Mars. And it had solar panels, so it was powered independently of Pathfinder. But Sojourner was only about this big, about 2 cats put together. Everyone says microwave. I prefer 2 cats. I can skip this. The atmosphere of Mars is mostly carbon dioxide. And if you saw in the picture, there were clouds there. They were not water clouds. They were carbon dioxide ice clouds, or dry ice. There's also dry ice on the surface. In fact, you see the North Polar ice cap there is almost completely dry ice. And it also exists in other places on the surface too, in this video will show. It's a bit kiddish, but the end result is really, really, really cool. So it's really interesting.
We were looking at these strange features on Mars. They're what we call linear gullies because they're long troughs. They can extend up to 2 kilometers, which is just over a mile. And they're really strange because they go down and then they end abruptly in a pit. A lot of features on the Earth that are similar, you end in a debris apron because stuff has been moved from the top to the bottom. But these don't have the apron, they just have a pit at the end, and so we were wondering how they could form. Frozen carbon dioxide accumulates on the surface, and we think that some of this accumulation will compress down and actually form ice slabs and ice blocks. We bought some frozen carbon dioxide, dry ice blocks, and we took it out to a dune slope and we put it down and we saw what happened. Most dune slopes will be at 33 degrees, and that's a nice steep slope. And so we did it with a water ice block, and the sand got wet and it didn't move, and we did it with a wooden block, and it moved 3 inches and then it stopped. The dry ice block, we expected to see a bit more activity, but we didn't expect it to just move and move and move and move and keep moving all the way to the bottom. But even on the other side of the dune, which is more like 6 degrees, it's very shallow, we put the block on and we pushed it and it would just slide right down, and the only reason it stopped is because it hit the bushes at the bottom. Dry ice, as it heats up, turns into gas. It pushes against the sand as it comes out. After a few hours, it's scooped out a nice little area, and so you have a feature that looks like what we see on Mars. They will move down that dune slope and carve out a shallow trough. When the block of ice is on the sand surface, that sand is just a little bit warmer, and so it causes a cushion of air to form, and that lifts that block just a little bit, so when it moves forward, it's like it's lubricated and it can just slide very easily. Then when it got to the bottom, instead of just sitting there, it would disappear as the area heated up, and then that could possibly leave a pit. I'm looking forward to the day when astronauts can engage in a whole new area of extreme sports. They could snowboard down these carbon dioxide covered dunes on a cushion of carbon dioxide. They would just shoot right down those slopes. It would be amazing.
Again, it was a little bit kiddish, but I thought it was real fun. And it is a personal goal of mine to go snowboarding on Mars. Yeah, could happen. All right, so a little bit later on, 2003, NASA had figured out how to send rovers to Mars. They did that with Pathfinder and little rover Sojourner. And it was time to send more, robots to Mars to do real science. And so NASA decided to send 2 geologists to Mars, and their names were Spirit and Opportunity. They launched in 2003 and got there in 2004. And just like Viking, NASA wanted to send 2, figure out what different areas were like, but also more redundancy. And so they were originally designed to last for 90 days. 3 months, it's not very long. But they were powered by solar panels, not batteries. And so they could be recharged as long as you wanted. Spirit lasted until about 2009. That's 5 years compared to 3 months design. And Opportunity is still driving ahead, which is, I think it's really amazing that the robot is still working. And a little bit after that, NASA decided to send an even better satellite to take more detailed photos of Mars. So the Mars Global Surveyor had a camera, but this is Mars Reconnaissance Orbiter. It has a telescope, and so MRO can take these amazing, beautiful, detailed photos of the surface. And it's taken some very, very lucky ones in the past. For example, whenever a lander lands on Mars, MRO has been there to take pictures of the descent. They have photos of planes going down on parachutes. It's really amazing. But here's some really lucky ones. That image up top is actually a meteorite strike. And you see that white stuff around the central crater. That's water ice. And it was later imaged, and they saw that the ice had evaporated, but not quite as quickly as dry ice would happen. So that's one of the ways they knew it was definitely water ice. Very, very lucky. Another image that I think is really, really awesome is that one there. And it's a little bit difficult to see, but there's a half-mile cliff there. Again, amazing half-mile cliff. But what's happening there is an avalanche. So it was really, really lucky that MRO happened to be orbiting the right place at the right time to get that image. But the takeaway message there is that Mars is not just this dead world. It has weather, It has changing landforms. It has meteorite strikes. It's a very, very active surface. And even though it doesn't have earthquakes and it doesn't have erupting volcanoes right now, there are things that are happening there that are really cool. As a side note, another cool thing with the weather is dust devils. Has anyone here actually seen a dust devil on Earth? I've only ever seen one in my whole video. You can YouTube this, taken by the rovers, of just 2 or 3 dust devils moving across the surface. And in one case, I think it was an opportunity. It had become covered by dust, and the solar panels were all caked with Martian dust. And a dust devil happened to go over at just the right time and sweep all of that off. That was really lucky, and also really cool. And the next lander was called Phoenix. Phoenix was its name meant that it was rising from the ashes of another lander that failed, the Mars Polar Lander. Phoenix went to the North Pole on Mars, and its job was also to search for ice. And so after Phoenix landed, and you can see there, it's landing on rockets because again, you can't use parachutes to land all the way to the ground. They don't really work. Phoenix dug a little bit under the soil and it saw ice, but it wasn't known whether it was water ice or carbon dioxide ice. So after a few days, or sols as they're called on Mars, it imaged there, they saw that some of it had evaporated, but not all of it. And so that's how they knew that it was definitely water ice. Another cool fact about Phoenix is how when it landed, NASA needed the best radio feed that it could get of the whole landing sequence. And so they turned to the best radio telescope they could find on Earth. And that was this one. Has anyone ever seen this one up close? Great Bank. So this is the Great Bank telescope. It's got an area about the same as a football field on its dish. It's about 100 meters by 110 meters. It's taller than the Statue of Liberty, and it's the largest steerable radio telescope in the entire world. And it's in West Virginia. It's in Pocahontas County. I think that's really, really cool. I've been there a ton of times, and it never, ever gets old. And if you're looking for somewhere cool to go on spring break, yeah. Anyway, go ahead, Justin. Actually, go back a bit. So the cool part about using Great Bank's telescope was it's so amazingly sensitive. In fact, because there were radio waves coming from this thing, that's what they were listening to. They were able to look at what's called the Doppler shift of all these radio waves coming in from the lander, all the way to the ground. And so as it fell through the atmosphere, they were able to tell its exact speed and direction as it fell through the air. Not only that, but they were able to compare that to the predicted speed of something falling through the Martian atmosphere. And all of the discrepancies were actually used to tell the wind speed and direction on the surface. So this telescope was that sensitive, that powerful. They were able to tell basically how fast the wind was blowing on Mars, millions of miles away, when a robot sighted. That's one of my favorite stories. And so after Phoenix, the next step was to send a bigger and better rover. And so NASA sent this one, Curiosity. You can see Sojourner the size of 2 cats. Spirit, kind of like a little golf cart thing or a go-kart. Curiosity, though, or the Mars Science Laboratory, as it's called, is about the size of an actual car. And it's also 6-wheel drive, and it can go just a little bit faster. It's going to last a long time because it's actually nuclear powered. It has a whole bunch of really, really interesting experiments I'll talk a little bit about, but I'll show you how it landed. So this was the biggest challenge of the entire planet. This Martian atmosphere, like I talked about before, it is too thin to use a parachute to go all the way to the ground. But it's there. So you have to worry about burning up on the entry. So NASA had this ultimate challenge of landing this giant robot on Mars. And they could not use airbags like they had before. Curiosity was simply too big to include the airbag. So this video shows how they solved it.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Mars. It landed just as it should have, and it's still on Mars today, taking pictures, doing science. So here's some of the photos that Curiosity took. There's one of Mount Sharp, and actually another one of Mount Sharp, and then you see some geological formations there that look a little bit like Utah, and it's thought that those layers of rock were deposited over time by water, just like layers on Earth. And here's another picture that Curiosity took. It's my favorite picture, and that's the Curiosity selfie. Curiosity has a little robot arm with a camera on it, so naturally the arm went out and like took the camera, took a selfie. But this right here is one of the most interesting parts. It's called ChemCam. And ChemCam has, you can see the camera there fairly well, but there's a little dot right next to the camera. Anyone see that? That's actually a laser. So Curiosity has a small, actually it's not small, it's pretty powerful. It's got a fairly powerful laser on it. And what that does is it will fire in short bursts far away the top layer of rock, and then the camera portion of ChemCam actually analyzes the smoke and dust that comes out to see what the rock is made of. It's one of my favorite parts of the whole rover. I remember, what was it? I think it was The Guardian, some tabloid in the UK, ran a story right after it landed. It was something like NASA lands robot. No, it was NASA lands nuclear-powered laser tank on Mars to hunt down aliens. And it was actually true. That's exactly what Curiosity was there for. It's there to search for life, for science and math life. It's nuclear-powered, it has a laser, and I think it looks like a tank. And so the next step, there are a couple more robotic missions. Those are to get ready for eventually sending people to Mars. And this is NASA's next long-term goal. NASA wants to send people into the outer solar system, first to the moon in lunar orbit, possibly to an asteroid. But the end goal is to send people to Mars by at least the mid to late 2030s. And so this is how it's going to look. We'll have people on the ground, where before we had to deal with the time delay. We had to deal with very limited locations about where we could send robots. We had to deal with robots that could crawl along the surface, yeah, but they only go about 1 or 2 miles per hour. You can't get a lot of science done that way, even though those rovers can some of the best ever built. In order to do real science on Mars, to do a lot of it, you need to send people. And so that's the next step. Some of the benefits, other than the amazing science for people to do, are we'll be able to figure out how to keep people alive in space for that long. If we want to send them even farther, we'll eventually, I hope, have self-sustaining kind of outpost on Mars. It won't be for much longer after we send it the first time, but if we can become a 2-planet species, I think that would be one of the coolest things about it. But there will be a lot of challenges as well. In fact, this is the part where I like to ask people about the challenges, because frankly, there are so many that there are some that we might not have thought of yet. So what are some of the challenges that we can think of for sending people to Mars? What makes it so difficult? Bringing water. You basically have to take all the water that you need, and the water that you will bring, you almost definitely will have to recycle, just like they do on the solar system. So think about that for a bit. It might not be a mission for the closest green mission, although I'm told that recycling water doesn't taste too bad. What's another challenge? Exactly. It'll be at least 6 months to get there and 6 months to get back. Because again, it has to follow a trajectory that's basically an orbit around the sun, kind of like the planets do. So during that time, people are going to have food, they're going to have air, and they're going to have personal space, because sharing a room that's actually probably a little bit smaller than this front stage area with 3 or 4 other people is definitely going to be tough. Some of the other challenges are, radiation shielding, because the full of harmful radiation that we need to protect people from. Although that could be a hidden benefit because if we can figure out how to protect people from this radiation on Mars, we may know a little bit more about how to protect them on Earth if we do it with medicine. Another challenge is cost. It's going to cost a lot of money to do this. It's something that NASA will need support for. It will need support of Congress and the entire country. But there are other groups looking to do the same thing. So Mars One is one company that looks to put people on Mars by 2023. I think it's a little bit ambitious, but they think they can do it. And their idea is to send people on a one-way trip. They don't want to bring the people back, or at least have them wait there until we can figure out how to bring them back, because we definitely don't know them. And as I was saying, that's one of the big things that makes putting people on Mars so expensive. You need to blast off from Mars just like from Earth, and for that you need all of that fuel. Remember that rocket from the beginning? That entire rocket is almost full of fuel for that tiny little robot. Well, it's not tiny, but again, a big rocket for not a lot of payload. You'll need to do the same thing on Mars. You need to figure out how to take fuel with you or get fuel there. But Mars One doesn't want to do that. Mars One says, let's send people on a one-way trip. How do they want to pay for it? They want to make a reality TV show. So I think I would enjoy that a little bit more than I enjoy American Idol and Survivor. But yeah, that does sound like the ultimate Survivor series. Hopefully people will keep watching. And there's another one. It's called Inspiration Mars. And Inspiration Mars is another group that wants to send people on a flyby mission. They don't want to break into orbit. They don't want to land. But they just want to send people close to Mars in 2018. And of course, the people would have to pay for it, but it would be the ultimate vacation, where Mars One would be the ultimate. And so now we'll talk a little bit about the role that West Virginia has in all this. So it's a little bit cheesy, but I like it. Country roads take me to Mars. I think this was made by WCW. But we're in Fairmont. You all know this place, yeah? This is the Independent Verification and Validation Center. Or is it Validation and Verification? What you got it right. Okay, fantastic. I always get the two confused, even though I kind of work there. Anyway, so IV&V does the software check for NASA science missions and for manned missions too. Basically, since these are robotic, and even the manned missions have a whole lot of computers on them, NASA needs to know for sure that all of the computers are going to work, that all of the software on the computers is going to work. And so it sends that all here, and that's where it's all checked for redundancy. And here are the missions to Mars that IV&V worked on. You see Mars Science Laboratory in the middle. This is my favorite. There's also MERAB. That's code name for Spirit and Opportunity. There's MRO and Phoenix. All of those missions work in part because NASA IV&V was there to check on all the software and make sure that when they were landing, when they were working, because NASA cannot fly these things to the ground, they have to fly themselves, but they would fly themselves right. Here's some of the other things that happen with IV&V. There's robotic training. So IV&V trains engineers and engineering students, and I think some science students, on how to build and operate these robots. So here's one. It's the top two pictures are a robot that's designed as a kind of all-terrain vehicle. Because there are no roads on this planet, we need to figure out ways to go off-road. Here's a robotic arm, but then my favorite one are those two cameras there. And notice they look a little bit like eyes, and that's because it's a stereoscopic camera. So the future missions to Mars, possibly, are going to have these stereoscopic cameras on that will be able to see Mars in 3D, not only so that we can send the public these beautiful 3D images, but also to make it easier to drive and see around rocks and stuff like that. And here's some of the future missions that IV&V is doing software checking for right now. In fact, this one right here, the satellite-looking thing, just been launched. Actually, it was launched about 3 months ago. It's called Maven. Maven is going to Mars, and it's going to figure out why the atmosphere isn't there. Mars used to have a thicker atmosphere than it does now. Perhaps almost as thick as the Earth, but no one knows why it's gone. There are theories about how the magnetic core stopped rotating. The magnetic field basically kind of died away. And like on Earth, magnetic field protects the atmosphere from being blown away by the sun, kind of like a force field. On Mars, magnetic field is barely there, so the atmosphere was essentially blown away. Maven wants to figure out how that happened. Another mission is called InSight. InSight's going to dig down about 16 feet. Get an idea of how cool that's going to be? The rovers have dug down about that much. So 16 feet is going to be a huge improvement. And one of InSight's jobs is to figure out why the core cooled down so much, which kind of ties into the atmospheric world of Maven. And then there's this. This is called Orion. And Orion is going to be NASA's next great station. Since the shuttles have been flying, we have not had the ability to put people in space on our own. We had to use the Russians. Orion's going to change that. In fact, Orion has its first test launch this year in September, and it's going to launch for the first time on its intended rocket in 2017, and that's a intended rocket. It's called the Space Launch System, and it has its first launch in 2017, like I said, and it's almost as big as the Saturn V, and it has some components of the Space Shuttle on it. But Orion is going to be able to go much farther than the Space Shuttle. It'll be able to go to the moon or even to near-Earth asteroids, where the shuttle was only able to go just a few hundred miles above. The shuttle had its time, and it built us the space station, but it's time to go far again. That's exactly what Orion is doing. And so one of the things you can do, actually, if you're interested, get on this right now. But IV&V has internships, and the deadline to apply is March 1st. So just how can they get to the application?
If you go to this website, for those who can't see it, just interns.nasa.gov, or you can Google NASA internships, and out there, something called Aussie NIPS. I think it's the One-Stop Shop Initiative for internships. And there are internships not only at NASA IV&V, but NASA centers all over the country. California, Florida, Texas, Alabama, Virginia, Maryland. So anywhere you like to go, any type of project you like to work on. So I encourage you to go out there, look at the website, look at all the opportunities that are available for you guys, and try to take advantage of that. If there's any help or any insight I can help you with, my name is Justin Smith. My email is justin.l.smith@nasa, and I can answer some questions for you as well.
And so I had said that sometimes on Mars the sky is blue, and here it is. It's a sunset on Mars. The picture is perfect, but that is a blue sunset. Their skies are normally pink or salmon colored, and sunrise and sunset are blue. I like to think of this as a sunrise, though, because I showed you all of the things that we've sent to Mars and going to send to Mars. I like to think that our day on Mars is really just beginning, especially for those of us who want to install the cool things that we have to do. So thank you all for watching. Oh, by the way, this is what made it possible. There's NASA, of course, NRAO, or National Radio Astronomy Observatory. They help. The Space Grant Consortium of West Virginia paid for it all. But then SPOT is what actually made this presentation. Justin and a couple other people from SPOT made this slideshow. And then basically we're a space public outreach team. We go around giving presentations just like this, except to middle schools, high schools, and some elementary schools too. So this is something that you're interested in doing, and it's really, really fun. That's why I do it. In fall, Justin's going to come here, and we're going to talk about starting a spot team at Fairmont. And you get paid. And by the way, you do get paid. It's what? It's $50 for every presentation. Plus, if you drive your own car, you get an extra $50.
If anybody has any questions for Nate or I, we'll stick around for a few minutes. But I appreciate you guys' attendance and coming out. So thanks, Nate. Thanks, Nate.